Hello everyone, I hope everyone is doing good and fine. Myself, Syed SAQUIB Ahmed. I am pursuing my graduation in mechanical engineering from Sri Venkateshwara College of Engineering, Bengaluru. I have taken a topic laser ignition system for internal combustion engines for my seminar. I have done this seminar under the guidance of Mr. Praveen Kumar K, Assistant Professor, Department of Mechanical Engineering, SVCE, Bengaluru. Let us discuss the contents which we are going to discuss in the seminar today. We are discussing the introduction to the laser ignition systems and what is laser and what is laser ignition and what are the types of laser ignition systems and we are going to see the setup of the laser ignition system, and we are also discussing the working principle of laser ignition system and why should we use the laser ignition and comparative advantages of laser ignition system with the spark ignition system, and some additional advantages of laser ignition system we are going to discuss, and also some disadvantages and future research which is need to be done in the future, and also the summary and the conclusion which I have given after studying about the laser ignition system and the references which I have taken to make this presentation. Let us move to the next slide. So, introduction. As we know, in the transportation and the energy production sector, internal combustion engine plays a dominant role, and in the technical appliances such as internal combustion engines, the adequate system performance of the reliable ignition is very much necessary. And unfortunately, in the conventional spark plug ignition, it just shows the major disadvantage with the modern spark plug guide combustion process, because it has not chosen optimal ignition location for this, and the laser ignition source has a potential of improving engine combustion with respect to the conventional spark plugs. So let us discuss what is laser. A laser is a device that produces an intense and focused and a coherent beam of light through a process which is called stimulated emission of radiation. And it is a acronym that stands for light amplification by stimulated emission of the radiations. As we can see in the picture here, I have shown the laser, this is how the laser looks and passes through an optic. So what is laser ignition system? A laser ignition system is a laser is a typically focused onto a small spot within the combustion chamber where the fuel is present. Okay, the laser beam rapidly hits the air fuel mixture, creating a high energy plasma which ignites the mixture, and then it initiates the combustion. The laser can be pulsed, and then the wavelength and the energy of the laser can be optimized for the specific fuel being used, allowing the efficiency and the clean combustion in this. And the laser ignition or the induced system is the process of starting combustion by the stimulus of a laser light sources. And as we can see here in the laser ignition, this is the laser beam which is passing through the convex lens which we are using to focus the laser light to the ignition location. These are let us discuss the types of the laser ignitions. Basically, energetic interactions of a laser with a gas may be classified into one of the following four schemes as described in below. This is first one is the thermal ignition. In this method, the suitable for fuel or oxidizer mixtures with strong absorption at the laser wavelength. However, in gaseous or liquid mixtures, it has an objections, like a objective thermal ignition is a unlikely a preferred choice to due to the energy absorption along these laser propagations directions. This method has been used successfully for solid fuels due to their absorption ability at the informed wavelength in this. Next one is the non-resonant breakdown. In this method, no base typically the light photon energy is invisible, and the UV range of the spectrum or the multi-photon process are required for molecular ionization in this. So this process shortly leads to an electron over uh, electron avalanche, and ends with the gas breakdown and the ignition, by for the most commonly used technique is the non-resonant ignition of the ignition, primarily because of the freedom is uh, selection of the laser wavelength and the ease of the implementation in this. The next type of the laser ignition is resonant breakdown. In this process, it involves the first a non-resonant multi-photon dissociation of a molecules and the resulting of freed atoms, okay, followed by a resonant photon ionization of these atoms, okay. In this process the generate in this process it generates the sufficient electron needed for a breakdown, and theoretically less input energy is required, okay, because due to the resonant nature of this method. And the last and the final laser ignition is a photochemical mechanism, okay. In this process, in this the approach is very little, due to the heating takes place and the laser beam begins about the molecular dissociation, leading to formation of radicals in this, okay. If the production rate of the radicals produced by this approach is higher than the recombination rate, then the highly active species will reach to the higher value, leading to an ignition ever, okay. In this, the radical number argumentation scenario is named as a chain branching in the chemical terms, okay. Let us go move to the laser ignition setup. So this is the laser ignition setup. Here we can see here the laser, in this is the laser source which is providing from this device, and this is we are using here the convex lens, and this is how the convex lens is focusing these laser beam into the optical fiber, which is helping the laser to project to the combustion chamber. This is how it is, an optical plug is connected to the chamber here. This is how the laser is moving here. This is the exhauster, and this in here the when the fuel is injected through the injector, and at the same time the combustion takes place, okay. This is the laser ignition setup. So let us discuss the working principle of the laser ignition systems, okay. The laser ignition system is the laser in our laser ignition system, a laser is typically focused onto the small spot within the combustion chamber, uh, where the fuel is kind of a presence, okay. The laser beam then rapidly heats the air fuel mixture inside the chamber, which creating a high energy plasma which ignites the mixture and the initiates the combustion. The laser can be pulsed there, okay, and the wavelength and the energy of the laser can be optimized for the specific fuel being used in the kind of a combustion process in the engine, allowing for the efficiency and the clean combustion of the fuel, which should be taking place here. So this is the process here. As you can see the piston and in this diagram you can see here. So let us discuss why we should use the laser ignition systems here. As you can see, it is a economic as well as the environmental constraints demand a future reduction in the fuel consumption and the exhaust emissions of a motor vehicle. At the moment, direct inject fuel energy flow the highest potential, reducing fuel consumption and the exhaust emissions in this. So the as we can see here in the first one, regulations on NOx emissions are pushing us towards the leaner air or a fuel ratios. Okay, these leaner air or fuel ratios are harder to ignite and they require higher ignition energies in this. Okay, spark plugs can ignite linear fuel mixtures but only by increasing spark energy. Unfortunately, these high voltages erode the spark plug, which contrast lasers, which ignites the air fuel mixture with the concentrated optical energy, have no electrode and are not affected, and they won't get eroded. And in the second, the natural gas is more difficult to ignite than the gasoline due to the strong carbon and the hydrogen bonds. Okay, so the laser are the monochromatic thing, so it will be much easier for the ignite natural gases, and the direct and and direct the laser beam to an optical optimal ignition locations in that. So the laser unfortunately, for the viewpoint of a gas engine or RB engine, ignition of the fuel lasers mixture by means of a laser has great potential in these things. Especially the thermodynamic requirement of a high compression ratio and a high power density are fulfilled. Will be by the laser ignition systems only. So, and also the optical wire and the laser setup is much smaller than the current spark plug models present now, allowing for a different design opportunities. The laser will be reduce erosions in the system, and the laser also produces more stable combustion, so you need to put less fuel into the cylinder, therefore increase the efficiency of the engine. Let us discuss the comparative advantages of the laser ignition system along with the spark ignition system which we are using in today's period. So in the spark ignition system, it has this less intense sparks when compared to laser ignition systems. Okay, the laser in the laser ignition system, it has a linear mixture. It has the ability to burn effectively the linear mixture. When it comes to the spark ignition system, it cannot burn the linear mixtures, and in spark ignition system, flame propagation is very slow when compared to the laser ignition system. And in spark ignition system, multi-point fuel ignition is not feasible. Easier possibilities of the multiple point ignition is very much possible in the laser ignition systems. So these are some of the additional advantages of a laser ignition system. As we know, it does not require a maintenance to remove the carbon deposits because of its self-cleaning property which the lasers has. Okay, and also it has a precise ignition timing possibilities in it, and also the high load or ignition pressure possibilities is is equal to increase in the efficiency, and the easier possibility of multi-point ignition is possible in this. Let us discuss the disadvantages of the laser ignition system. As it has a high cost. When it comes to the cost, it can be more expensive than the traditional spark plug systems. The laser used in laser ignition system can be complex and require precise optics, which can add the overall cost of the system in this. And also the laser induced optical damages, and also the concept proven but not commercial. The commercial system physically not yet available in the market, and also the complexity, it is more complex than traditional spark plug systems, okay, requiring sophisticated optics, electronics, and the control systems for this, okay. And other another disadvantages is the power requirement. It requires a significant amount of energy to generate the high energy laser beams needed for ignition process. These are the disadvantages of the laser ignition systems. The future work which is needs to be done and the shortcomings which are coming is, okay, let us discuss one by one. The laser parameter optimization, okay. In this, the first one is the laser parameters optimization, which includes the wavelength, pulse duration, energy, and the focus part size can be significantly affect the ignition process of the engine and the combustion dynamics, okay, which has to be done in the future, because the understanding of the combustion dynamics for laser ignition includes the ignition delay and the flame propagations, etc., has to be done in the research work. And the durability and the reliability, in the research has to be uh, mm, declare that the laser ignition system that are re bust, robust, reliable, and have a long service life in it. And also, we are they have to make it cost effectiveness, because they have to work on the system where it can be affordable for all the people. And when it comes to the fuel flexibility, it has have a primarily been studies with the conventional gasoline engines, and the performance with the alternative fuels such as the biofuels and the hydrogen and the natural gas further has to be done in the research. And if we need to know, these are some of the future research which has to be done. And the summary of the laser ignition system. The laser ignition has the potential to generally improve the existing and the future artillery systems, and it is safer, and it is environmentally friendly, and it is reliable, and it is automated. It has the automated operation system, and the technology driven system improvements have has there, and it is versatile, and it is flexible. This is the conclusion which I have give, which I have written after making, after studying about the laser ignition system. The laser ignition system allows almost free choice of the ignition location within the combustion chamber, even inside the fuel spray. And the significant reduction in fuel consumption, as well as the reductions of the exhaust gases, shows the potential of the laser ignition process. Laser ignition is non-intrusive in the nature, high energy can be rapidly deposited, and has the limited heat losses, and it is capable of a multi-point ignition of the combustion charges. So these are the references which I have used to make this presentation. And thank you so much for seeing this presentation till here. If you have liked this presentation, please give it a thumbs up and share this with your friends. Thank you so much.